Hey guys! So we are here for another STEM activity. This week's craft, or this month's craft, is exploding soap. So you should have gotten at the library this kit. All it has is just your URL to get to this YouTube channel and a bar of Ivory soap. So the other things you're going to need a plate. Paper plate makes it easy because you can just toss it after. And you might need a knife, just depending on how easy it is for you to break up the soap. So you're also going to need a microwave, and you're going to have to make sure that your parent or caregiver is okay with your microwave smelling like soap for at least a while after, because it smells like Ivory soap. It's not a bad smell, but it is a very definite smell, and when it mixes with food it's a little weird. So if you try and microwave food in there after the smell might be a little weird. So once you've got that all cleared up, then you're gonna want to take your soap and unwrap it. Today we're going to learn about Charles's law with this soap, but I will tell you about that after we get this things rolling. So first, if you can manage it, or if your caregiver does this for you, you'll want to break it in half. Oh, got it. Okay, so you'll notice when you break it in half, there's a bunch of little ridges in there that you wouldn't normally see if you cut it in half with a knife, which is why I wanted you to break it first. So it's actually full of air. Ivory soap is famous for being the soap that floats. So you could actually stick this in water and it would float. So once you've done that, feel free to just take your knife and cut it into quarters. It's a lot easier. Okay. And then you will want to stick it in the microwave for a minute. And then see what happens. Okay, we've got Austin zooming in now. So I want to tell you a little bit about the history of Ivory soap. So, like back in the day, one of the employees had left his mixing machine on and noticed that when he came back, his batch of soap had like doubled in size because of how much air was whipped into it. They made the soap and it floats, right? It floated, and then they decided to just keep it that way. So that Ivory soap became the soap that floats, and if you tested other soaps out, most of them don't float. Oh my gosh, there it goes. Oh, that's so cool. It's almost like, it's kind of like your marshmallow effect if you stick a marshmallow in. It's kind of the same principle. Oh, that's huge. It's getting so tall. Yes. Awesome. Alright. Look at this. Oh my gosh. It just looks unreal. It's so cool. Okay, so it might be hot. Like the thicker parts of it might still be hot, so you just want to be careful, but that's so cool. It's so squishy. So what just happened, right? So we know that the soap has more air in it than other soaps, and these big chunks here, these are definitely more hot, so you could probably even stick this in a little longer because these ones didn't quite explode. Anyway, it feels like crisp sugar almost. It's very squishy and satisfying. So what happened? Okay, science here. The soap is filled with more air bubbles, and they have water molecules in there with them, and as the water heats up, it vaporizes, and Charles's law is that as a gas increases in temperature, it increases in volume. So the air in the soap expands and pushes everything out in this beautiful mess right here. So this soap, you can play with it. You could wash your hands with it still. It's just now it's taken a different form and texture, which is just super cool. So I hope you guys enjoyed this STEM project, and we will catch you next time. See ya.